Hello everyone, welcome back. Today I'm going to talk about homework 6 and this is question 1. And question 1 is giving us that density function xy equals to 1 plus xy over a, that absolute value of x is less than 1 and absolute value of y less than 1. So the first question is ask us to find a so that above definite is a valid joint density function. It means that if we integral from minus infinity to infinity of this density function, it equals to 1. So it can be transferred into this density function integral from minus 1 to 1 according to delta x, and integral from minus 1 to 1 according to delta y. And we can write it as 4 of a equals to 1, so that a equals to 4. The second question is asked that are x and y are uncorrelated. So if we want to prove that xy is uncorrelated or not, we have to calculate the expectation of xy and individual expectation of x and y. Firstly, we calculate the expectation of xy. So it equals to xy multiplied by the density function xy, integral from minus 1 to 1 according to x, and integral from minus 1 to 1 according to delta y. And it can be written into this equation, and we can calculate it as result as 1 over 9. And the expectation of x can be also written as x multiplied by density function integral from minus 1 to 1 according to delta x, and integral from minus 1 to 1 according to delta y. And we calculated it as 0. So when we arrive at this step, we know that it cannot equal, because expectation of x multiplied y cannot be equal to 0, but the right side is equal to 0, so xy are not uncorrelated. So it can also be derived to, we can also conclude that xy are not independent because it's uncorrelated. So question 4 is giving us that it's asked about to finding the joint density function of x squared and y squared, and we can write z equals to x squared and w equals to y squared, and we can write the j combination function matrix as this, and we can know j equals to 4xy. If we want to gauge the density function of zw, we just write the fxy, density function of xy, when we plug in the transform function from x to z over the j, and we accumulated all these possible equations to gauge the density function of zw. Is this the result? So we can, yes, this is the result. And if we want to prove or disprove that x squared and y squared are independent, we have to write down the density function of zw is calculated from above. Also, we have to calculate the individual density function of z and density function of y of w, and we can easily observe that if density function z multiply density function of w equals to density function zw, so z and w are independent, and we know that z and w can be transferred into x and y, so we can also get the conclusion that x squared and y squared are independent. So that's the result. Thank you.